@NCERT video welcomes you. Today we are going to start Chapter 7 Fractions. Let's start Chapter 7 Fractions. Recall that when some whole number of things are shared equally among some number of people, fractions tell us how much each share is. Subnum. Do you remember if one roti is divided equally between two children, how much roti will each child get? Mukta. Each child will get half a roti. Sabnam. The fraction 1 half is written as 1 by 2. We also sometimes read this as 1 upon 2. Mukta, if one roti is equally shared among 4 children, how much roti will one child get? Sabnam, each child's share is 1 upon 4 roti. Mukta, and which is more, 1 upon 2 roti or 1 upon 4 roti? Sabnam, when two children share 1 roti equally, each child gets 1 by 2 roti. When 4 children share 1 roti equally, each child gets 1 by 4 roti. Since in the second group, more children share the same roti, each child gets a smaller share. So, 1 upon 2 roti is more than 1 upon 4 roti. You can see it here. This is 1 upon 4 and this one 1 upon 2. So 1 upon 2 is more than 1 upon 4. One upon 2 is double of 1 upon 4. You can see it here. I have doubled 1 upon 4. Seven point one fractional units and equal shares. Beni, which fraction is greater, 1 upon 5 or 1 upon 9? Arvin, 9 is bigger than 5. So I would guess that 1 upon 9 is greater than 1 upon 5. Am I right? Beni, no. That is a common mistake. Think of these fractions as shares. Arvin, if one roti is shared among 5 children, each one gets a share of 1 upon 5 roti. If one roti is shared among 9 children, each one gets a share of 1 upon 9 roti. Beni, exactly. Now think again. Which share is higher? Arvin, if I share with more people, I will get less. So 1 upon 9 is less than 1 upon 5. Beni, you got it. Oh, so 1 upon 100 is bigger than 1 upon 200. Kindly think this is true. When one unit is divided into several equal parts, each part is called a fractional unit. These are all fractional units. 1 upon 2, 1 upon 3, 1 upon 4, 1 upon 5, 1 upon 6 and so on, 1 upon 10 and so on, 1 upon 50 and so on, 1 upon 100 etc. We also sometimes refers to fractional units as unit fractions. Figure it out. Fill in the blanks with fractions. 1. 3 guavas together weigh 1 kg. If they are roughly of the same size, each guava will roughly weigh dash kilogram. It is given 3 guavas weigh 1 kilogram. Then 1 guava will weigh 1 by 3 kilogram. The answer is 1 upon 3. 2. A wholesale merchant packed 1 kilogram of rice in 4 packets of equal weight. The weight of each packet is dash kilogram. 4 packets weigh 1 kilogram. Then 1 packet will weigh 1 upon 4 kilogram. 3. 4 friends ordered 3 glasses of sugarcane juice and shared it equally among themselves. Each one drank dash glass of sugarcane juice. 4 friends has 3 glasses of sugarcane. Then one friend will have 3 upon 4 glasses of sugarcane. The answer is 3 upon 4. 4. The big fish weighs half kilogram. The small one weighs quarter kilogram. Together they weigh dash kilogram. You have to add them. You can think like this. If this is 1 kilogram, then this one is the portion occupied by big fish. Similarly, this one by small fish. So, if 1 kilogram divided into 4 parts, both fish will weigh 3 upon 4 kilogram. You can see 3 shaded region out of 4. The answer is 3 upon 4. Knowledge from the past. Fractions have been used and named in India since ancient times. In the Rig Veda, the fraction 3 upon 4 is referred to as Tripad. This has the same meaning as the word for 3 upon 4 in many Indian languages today. Example, Teen Pav in colloquial Hindi and Mukkal in Tamil. Indeed, words for fractions used today in many Indian languages go back to ancient times. Find out and discuss the words for fractions that are used in the different languages spoken in your home, city, or state. Ask your grandparents, parents, teachers, and classmates what words they use for different fractions, such as for 1 and a half, 3 quarters, 1 and a quarter, half, quarter, and 2 and a half. And write them here. In Hindi, half is said as adha, 3 by 4 said as teen pav, similarly 1 and half, डेढ़, 2 and half, अढ़ाई, Similarly, 1 and 1 by 4, that is 1 and quarter, sawa. You can write it here. 5. Arrange these fraction words in order of size from the smallest to the biggest in the empty box below. 1 and a half, 3 quarters, 1 and a quarter, half, quarter, 2 and a half. 1 and a half, that is 1 plus 1 by 2. 3 quarters, that means 3 by 4. 1 and a quarter, that is 1 and 1 by 4. Half, 1 by 2. Quarter, 1 by 4. 2 and a half, that is 2 plus 1 by 2. You can see the smallest one is quarter, that is 1 by 4. Then 1 by 2, that is half. Then 3 quarters, that is 3 by 4. Then 1, it is not here. Then 1 and 1 by 4, that is 1 and a quarter. Then 1 and half. Then 2 and half. Here the fractions has been arranged from the smallest to the biggest one. 7.2 Fractional units as parts of a whole. The picture shows a whole chicky. A whole chicky. You can see the chicky has been divided into 6 vertical parts and 4 horizontal parts. You can say 6 units length and 4 units width, such that it has an area of 6 into 4, that is 24 square units. You can see 24 small square units here of this size, which I am shading. Below, a picture of the chicky broken into 2 pieces is shown. How much of the original chicky is each piece? You can see the whole chicky has been divided into 4 parts. 1, 2, 3, 4. So this part is 1 upon 4 and this 3 upon 4. We can see that the bigger piece has 3 pieces of 1 upon 4 chicky in it. So we can measure the bigger piece using the fractional unit 1 upon 4. We see that the bigger piece is 3 upon 4 chicky. You can see it here. This is 1 upon 4 and this one 3 upon 4. A whole chicky cut into 6 equal pieces, such that this piece is called 1 upon 6. You can see 6 such pieces. 1, 2, 3, 4, 5, 6. A whole chicky cut into 6 equal pieces in a different way. You can see here it has been cut in 6 triangles such that all the triangles are of the same area. So one piece is equal to 1 upon 6. By dividing the whole chicky into 6 equal parts in different ways, we get 1 upon 6 chicky pieces of different shapes. Are they of the same size? You already know area of a triangle is half of the rectangle formed by its double. So this area is half of the area of this rectangle. Kindly compare this triangle with this triangle. You can see it has 2 units width and 1, 2, 3, 4. 4 units height. So 4 into 2, area of triangle will be 4 into 2, that is 8 square units. You already know area of a triangle is half of the rectangle formed by its double. So this area is half of the area of rectangle. The rectangle has 2 units width and 4 units height. Area of rectangle is 4 into 2. That is half of 8, that is 4 square units. If you count it here, you will get 4 square units in this 1 by 6 part. This also has an area of 4 square units. So you can say this part of the chicky has the same area of this part. So you can say both are of the same size. What is the fractional unit of chicky shown below? You can see the whole chicky has been divided into 3 parts. 1 part, 2 part, and this one, third part. So you can say one part has area of 1 by 3 of the whole chicky. We get this piece by breaking the chicky into 3 equal pieces. So this is 1 by 3 chicky. 1 by 3 or 1 upon 3. A whole chicky is here and 1 upon 3 chicky is here. Figure it out. The figures below shows different fractional units of a whole chicky. How much of the whole chicky is each piece? You can see 1 and 2, 2 pieces out of 24, that is 1 upon 12. You can see this has an area of half of the rectangle drawn here. So this piece will have area of half of 4 into 3, that is half of 12, that is 6, and 6 out of 24 is 1 upon 4. There is another method of doing that. You already know any shape of like this, just more than half like this or like this has area of 1 square unit. Any shape having area exactly half of 1 square unit is counted as half square unit, and any shape with area less than that is counted as 0 square units. Figure it out. The figures below shows different fractional units of a whole chickpea. How much of a whole chickpea is each piece? You can see 2 pieces out of 24 pieces. So fractional unit will be 1 upon 12. Similarly, you can see a chickpea in the shape of triangle. You already know area of triangle is half of the area of the rectangle formed by its double. Area of this rectangle will be 3 into 4, that is 12. Half of 12 will be 6. 6 pieces out of 24. That will be 1 upon 4. There is another way of doing that. You already know 1 square unit, or just more than half, is counted as 1 square unit in area. Exactly half is counted as half, and less than half is counted as 0. So this piece of chickpea has 1, 2, 3, 4, 5, and this one more than half, 6. 6 pieces out of 24. So you can say 6 out of 24 or 1 upon 4. Similarly, you can find the area of this piece of chickpea. Half of 3 into 2, that is half of 6, that is 3. 3 out of 24 is 1 upon 8. You can use this method. 1, 2, 3. 3 out of 24, that is 1 upon 8. Similarly, D, 1 piece, 2 piece, 3 and 4, 4 square units out of 24. So the unit fraction will be 1 upon 6. E, 1, 2 and 3 square pieces out of 24 square pieces. The answer is 1 upon 8. Similarly, this rectangle or this square will have the area of 1, 2, 3, 4. So the triangle will have area of half of 4, that is 2. Similarly, this one half of 4, that is 2. 2 plus 2, 4. 4 out of 24. The answer will be 1 upon 6. G, you can see 1 square unit out of 24. The answer is 1 upon 24. H, you can see a chickpea in triangular shape. Area of this chickpea will be half of 1 and 2, that is 1 square unit. 1 square unit out of 24. The answer is 1 upon 24. You can count it like this. This is more than half, so counted as 1, and this one 0. The answer will be 1 upon 24. 7.3 Measuring using fractional units. Take a strip of paper. We consider this paper strip to be 1 unit long. One strip paper. Its length is 1 unit. Fold the strip into 2 equal parts and then open up the strip again, taking the strip to be 1 unit in length. What are the lengths of the 2 new parts of the strip created by the crease? You can see this portion is half of 1 unit length, so written as half, and the other one also written as half. What will you get if you fold the previously folded strip again into 2 equal parts? You will now get 4 equal parts. You can see half of half, that is 1 upon 4, 1 upon 4, 1 upon 4, 1 upon 4. This length is 2 times 1 upon 4, that is 2 upon 4, can be written as half. This length is 3 times 1 upon 4, can be written as 3 upon 4. This length is 4 times 1 upon 4, written as 4 upon 4 or 1. Do it once more. Fill in the blank boxes. You can see 1 unit length paper strip has been splitted in 8 equal parts. 1, 2, 3, 4, 5, 6, 7, 8. So one part will be 1 upon 8. 2 times 1 upon 8 is 2 upon 8 or 1 upon 4. 3 times 1 upon 8 is 3 upon 8. 4 times 1 upon 8 is 4 upon 8 or can be written as 2 upon 4 or 1 upon 2. 5 times 1 upon 8 is 5 upon 8. Similarly, 6 times 1 upon 8 is 6 upon 8, can be written as 3 upon 4. Similarly, 7 times 1 upon 8 can be written as 7 upon 8. Similarly, 8 times 1 upon 8 can be written as 8 upon 8 equal to 1. Fractional quantities can be measured using fractional units. Let us look at another example. This circle represents a full roti whole. So this will be half, 1 times half. 2 halves, that is 1 by 2, plus 1 by 2, that is 2 times half. Similarly, this is 3 times half or 1 upon 2 plus 1 upon 2 plus 1 upon 2. 4 times half, 5 times half, and so on can be written. We can describe how much the quantity is by collecting together the fractional units. Figure it out. 1. Continue this table of half for 2 more steps. Similarly, you have to find 6 times half here and then 7 times half and draw the figure of half circles. here and add half 6 times. You can do it for 7 times half as well. 2. Can you create a similar table for 1 upon 4? Try doing that. 3. Make 1 upon 3 using a paper strip. Can you use this to also make 1 upon 6? Yes, you can do that. If this is 1 unit length paper strip, it should be folded in such a manner that it has 3 equal parts. One part will be 1 upon 3. It should be folded again such that you get exactly half of 1 upon 3, such that this unit length paper strip has 6 equal parts. So one part will be 1 upon 6. You can see 1 upon 3 is double of 1 upon 6. 4. Draw a picture and write an additional statement as above to show A. 5 times 1 upon 4 of a roti. B. 9 times 1 upon 4 of a roti. You know 4 times 1 upon 4 is equal to 1. 5 times means 4 into 1 upon 4, 4 times 1 upon 4 plus 1, 1 upon 4. That is 1 plus 1 upon 4. It can be drawn like this: 1 roti and a quarter roti. You can see 1, 2, 3, 4. That is 1 upon 4, 4 times, and this one again 1 upon 4. That means 5 times 1 upon 4. Similarly, you can draw 9 times 1 upon 4 of a roti. You will get 2 circles or 2 roti and a quarter roti. You can see 8, 1 upon 4 and the ninth one here. 9 times 1 upon 4 of a roti. 5. Match each fractional unit with the correct picture. You have to match it. This is 1 upon 8. This is 1 upon 6. This is 1 upon 3. And this one 1 upon 5. Reading fractions. We usually read the fraction 3 upon 4 as 3 quarters or 3 upon 4. But reading it as 3 times 1 upon 4 helps us to understand the size of the fraction because it clearly shows what the fractional unit is and how many such fractional units there are. Recall what we call the top number and the bottom number of fractions. In the fraction 5 upon 6, 5 is the numerator and 6 is the denominator. Similarly, 3 upon 4, 3 is numerator and 4 is denominator. Teacher's note: give several opportunities to children to explore the idea of fractional units with different shapes like circles, squares, rectangles, triangles, etc. 7.4 Marking fractional lengths on the number line. We have marked lengths equal to 1, 2, 3 dash 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 units on the number line. Now let us try to mark lengths equal to fractions on the number line. What is the length of the blue line? Write the fraction that gives the length of the blue line in the box. You can see from here to here it is 1 unit length and blue line is half of 1 unit length. That is, blue line will have length of half units. You can see a number line given here 0, 1, 2 and so on can be written. The distance between 0 and 1 is 1 unit long. It is divided into 2 equal parts. So the length of each part is 1 upon 2 unit. So this blue line is half unit long. Now can you find the lengths of the various blue lines shown below? Fill in the boxes as well. 1. Here the fractional unit is dividing a length of 1 unit into 3 equal parts. Write the fraction that gives the length of the blue line in the box or in your notebook. You can see a number line given here 0, 1, 2. Unit length has been divided into 1, 2 and 3 equal parts. So this one is 1 by 3 or 1 upon 3. This is 2 upon 3 and 1 can be written as 3 upon 3. 0 can be written as 0 upon 3. So the length of blue line will be 2 upon 3. Similarly, this sequence can be extended to 4 upon 3, 5 upon 3, 2 can be written as 6 upon 3. Similarly, 7 upon 3, 8 upon 3 and so on. 2. Here a unit is divided into 5 equal parts. Write the fraction that gives the length of the blue lines in the respective boxes or in your notebook. You can see a unit length has been divided into 1, 2, 3, 4, 5, 5 equal parts, such that one part is 1 upon 5, second one 2 upon 5, that is length of this blue line. Third one 3 upon 5, this one 4 upon 5, that is length of this blue line. Similarly, you can write 1 as 5 upon 5, then 6 upon 5, 7 upon 5, 8 upon 5, 9 upon 5, 2 as 10 upon 5, similarly 11 upon 5, 12 upon 5 and so on. 3. Now a unit is divided into 8 equal parts. Write the appropriate fractions in your notebook. 0, 1, 2. Unit length has been divided into 8 equal parts. Like this, such that this is 1 upon 8, this one 2 upon 8, 3 upon 8, 4 upon 8, 5 upon 8, 6 upon 8, 7 upon 8 and 8 upon 8 for 1. Similarly 9 upon 8, 10 upon 8 and so on. 0 can be written as 0 upon 8, 2 can be written as 16 upon 8. Figure it out. 1. On a number line, Draw lines of length 1 upon 10, 3 upon 10 and 4 upon 5. For this you have to split a unit length into 10 equal parts. Zero, 1 upon 10, 2 upon 10, 3 upon 10, 4 upon 10, 5 upon 10, 6 upon 10, 7 upon 10, 8 upon 10, 9 upon 10 and 10 upon 10, that is 1. 1 upon 10 is here, 3 upon 10 is here. For 4 upon 5, you have to split a unit length into 5 equal parts, like this. You can see this is 1 upon 5, 2 upon 5, 3 upon 5, 4 upon 5 and this one 5 upon 5 or 1. You can see 4 upon 5 is equal to 8 upon 10. If you divide 8 by 2 and 10 by 2, you will get 4 upon 5. 2. Write 5 more fractions of your choice and mark them on the number line. Try doing that. 3. How many fractions lie between 0 and 1? Think, discuss with your classmates and write your answer. The answer is infinite. There are infinite fractions lying between 0 and 1. You can write, for example, 1 upon 99 is there between 0 and 1. 1 upon any number you can write here is also there between 0 and 1. So the answer is infinite. 4. What is the length of the blue line and black line shown below? The distance between 0 and 1 is 1 unit long and it is divided into 2 equal parts. The length of each part is 1 upon 2, that is half. So the blue line is 1 upon 2 units long. Write the fraction that gives the length of the black line in the box. You can see here a unit length has been divided into 2 parts. This blue line has length of half unit length. Similarly, the black one will have length of 3 upon 2 unit length. You already know 0 can be written as 0 upon 2, 1 upon 2 here, 1 can be written as 2 upon 2. Similarly, this one 3 upon 2 and 2 can be written as 4 upon 2. 5. Write the fraction that gives the length of the black lines in the respective boxes. You can see 0 here, 1 upon 5, 2 upon 5, 3 upon 5, 4 upon 5. This one 5 upon 5 or 1. Here 6 upon 5, 7 upon 5, 8 upon 5, 9 upon 5. Similarly, 2 can be written as 10 upon 5. Teacher's note. Draw these lines on the board and ask the students to write the answers in their notebooks. 7.5 Mixed fractions. Fractions greater than 1. You marked some fractions on the number line earlier. Did you notice that the lengths of all the blue lines were less than 1 and the lengths of all the black lines were more than 1? Write down all the fractions you marked on the number line earlier. You can see length of blue line is less than 1 and length of black lines is more than 1. You can write the fractions of these here in the box. Now let us classify them into two groups: length less than 1 unit, length more than 1 unit. You can write here 1 upon 2, 1 upon 4, 1 upon 8, 5 upon 8, 3 upon 4, 6 upon 10, 1 upon 6, and so on, whose numerator is less than denominator, and length more than 1, that is, whose numerator is greater than denominator. For example, 5 upon 4, 6 upon 5, 7 upon 4, 3 upon 2, 8 upon 5, 7 upon 6 can be written here. Did you notice something common between the fractions that are greater than 1? In all the fractions that are less than 1 unit, the numerator is smaller than the denominator, while in the fractions that are more than 1 unit, the numerator is larger than the denominator. We know that 3 upon 2, 5 upon 2 and 7 upon 2 are all greater than 1 unit. But can we see how many whole units they contain? 3 upon 2 can be written as 1 upon 2 plus 1 upon 2 plus 1 upon 2. 1 upon 2, 1 upon 2, that is half and half, makes whole or 1, and the half remain here. 3 upon 2 can be written as 1 plus half, that is 3 upon 2 is more than 1. Similarly, 5 upon 2 can be written as 5 half added, it will give 2 plus half, that is more than 1. This girl says, I know that 1 upon 3 plus 1 upon 3 plus 1 upon 3 is equal to 3 upon 3 is equal to 1. If I add one more, 1 upon 3, I will get more than 1 unit. So 4 upon 3 is greater than 1. Figure it out. 1. How many whole units are there in 7 upon 2? 7 upon 2 can be written as 1 upon 2 plus 1 upon 2, 1 upon 2, 7 times. Half and half 1, half and half 1, half and half 1. That means 1 plus 1 plus 1 plus half, that is 3 plus half. There are 3 whole units in 7 upon 2. 2. How many whole units are there in 4 upon 3 and in 7 upon 3? 4 upon 3 can be written as 1 upon 3, 1 upon 3, 1 upon 3, 1 upon 3 4 times. 3 1 upon 3 is equal to 3 upon 3, that is 1 plus 1 upon 3. That means number of whole units in 4 upon 3 is 1. Similarly, in 7 upon 3, you have to write 7 times 1 upon 3 and add them. Three times 1 upon 3, 3 times 1 upon 3 is equal to 1 plus 1 upon 3, that is 2 plus 1 upon 3. That means there are 2 whole units in 7 upon 3. Writing fractions greater than 1 as mixed fractions. We saw that 3 upon 2 is equal to 1 plus half. We can write other fractions in a similar way. For example, 4 upon 3 can be written as 1 upon 3 plus 1 upon 3 plus 1 upon 3 plus 1 upon 3 equal to 1 plus 1 upon 3. 3 times 1 upon 3 is equal to 1. Figure it out. 1. Figure out the number of whole units in each of the following fractions. A. 8 upon 3. 8 upon 3 can be split in 6 upon 3 plus 2 upon 3. So it can be written as 2 plus 2 upon 3. So 8 upon 3 has 2 whole units. B. 11 upon 5. It can be split in 10 upon 5 plus 1 upon 5. That is 2 plus 1 upon 5. That means 11 upon 5 has 2 whole units. C. 9 upon 4. It can be split in 8 upon 4 plus 1 upon 4, such that it is equal to 2 plus 1 upon 4. So 9 upon 4 has 2 whole units. We saw that 8 upon 3 is equal to 2 plus 2 upon 3. 8 upon 3 is fraction, and if a fraction is more than 1 and written in this way, it is called a mixed number because it is mixture of two numbers. So it is called mixed number. This number is thus also called 2 and 2/3. We also write it as 2 whole 2 upon 3. Kindly note that 2 plus 2 upon 3 can be written as 2 whole 2 upon 3. 2. Can all fractions greater than 1 be written as such mixed numbers? Yes, it is possible. For example, 1 plus 1 upon 4 can be written as 1 whole 1 upon 4. Similarly, 2 plus 1 upon 2 can be written as 2 whole 1 upon 2. A mixed number or mixed fraction contains a whole number called the whole part and a fraction that is less than 1 called the fractional part. You can see this is whole part, whole part, whole part, and this is called fractional part, which is less than 1. 3. Write the following fractions as mixed fractions. Example, 9 upon 2 is equal to 4 whole 1 upon 2. There is a trick of doing that. You have to divide 9 by 2. 4 times 2 is 8, remainder is 1. You already know 2 is divisor, 9 is dividend, 4 is quotient, and 1 is remainder. The pattern of a mixed fraction is quotient, whole, remainder upon divisor. So on dividing 9 by 2, you get quotient 4, remainder 1, and divisor is 2. A 9 upon 2. 9 upon 2 can be splitted in 8 by 2 or 8 upon 2 plus 1 upon 2. You can write it as 4 plus 1 upon 2 or 4 whole 1 upon 2. B. 9 upon 5. 9 upon 5 can be splitted in 5 upon 5 plus 4 upon 5. 1 plus 4 upon 5 or 1 whole 4 upon 5. C. 21 upon 19. It can be splitted in 19 upon 19 plus 2 upon 19 or 1 plus 2 upon 19 or 1 whole 2 upon 19. Similarly, D. 47 upon 9. 47 upon 9 can be splitted in 45 upon 9 plus 2 upon 9, 5 plus 2 upon 9 or 5 whole 2 upon 9. Another way of doing that, remainder is 2. So 47 upon 9 can be written as quotient 5 remainder 2 upon divisor, that is 9. Similarly, E. 12 upon 11. 12 upon 11 can be written as quotient, remainder and divisor. You can see quotient is 1, remainder is 1 and divisor is 11. Similarly, F. 19 upon 6. 19 upon 6 can be written as 18 upon 6 plus 1 upon 6 or 3 plus 1 upon 6 or 3 whole 1 upon 6. Another way of doing that, divide 19 by 6. You will get 3 as quotient, 1 as remainder and 6 as divisor. So 19 upon 6 can be written directly as quotient whole remainder upon divisor. This girl says, can we write a mixed fraction as a regular fraction? This girl replies, yes, I figured out a way to write a mixed number as a regular fraction. Jaya, when I have 3 plus 3 upon 4, this means 1 plus 1 plus 1 plus 3 upon 4. I know 1 is equal to 1 upon 4 plus 1 upon 4 plus 1 upon 4 plus 1 upon 4. So I get these numbers, that is 1 plus 1 plus 1 plus 3 upon 4 is equal to 15 upon 4. Another way of doing that, a mixed fraction such as 3 whole 3 by 4 or 3 plus 3 upon 4, just multiply the denominator to the whole number or whole part of the mixed fraction and add the numerator, that is 4 into 3 plus 3 upon 4, 12 plus 3 upon 4 or 15 upon 4. Therefore, 4 into 1 upon 4, 4 into 1 upon 4 4 into 1 upon 4. 3 into 1 upon 4 when added will give you 15 upon 4. Figure it out. Write the following mixed numbers as fractions. A. 3 whole 1 upon 4. 3 whole 1 upon 4 can be written as 3 plus 1 upon 4. This can be written as 1 plus 1 plus 1 plus 1 upon 4. So, you can write this one as 4 upon 4, 4 upon 4, 4 upon 4 for this one, and 1 upon 4. When added will give you 4, 4, 8, 4, 12 and 1, 13, 13 upon 4. Another way of doing that, 3 whole 1 upon 4, just multiply the denominator to the whole part and add the numerator. That is 4 into 3 plus 1 upon 4. 12 plus 1 upon 4 is equal to 13 upon 4. B. 7 whole 2 upon 3. You can do using second method, 3 into 7 plus 2 divided by 3. 21 plus 2 upon 3. That is 23 upon 3. The answer is 23 upon 3. C. 9 whole 4 upon 9. 9 into 9 plus 4 upon 9. 85 upon 9. D. 3 whole 1 upon 6. 6 into 3 plus 1 upon 6. That is 18 plus 1 upon 6 or 19 upon 6. E. 11 into 2 plus 3 upon 11. 25 upon 11. F. 10 into 3 plus 9 upon 10 equal to 39 upon 10. 7.6 Equivalent fractions. Using a fraction wall to find equal fractional lengths. In the previous section, you used paper folding to represent various fractions using fractional units. Let us do some more activities with the same paper strips. You can see a paper strip of unit length, half here, and 2 1 upon 4, that is 2 upon 4. 2 times 1 upon 4. This is 1 upon 4, this one 1 upon 4. So 2 times 1 upon 4 is equal to 2 upon 4. You can see half is equal to 2 upon 4. 2 upon 4 is equal to half. You can divide numerator and denominator by 2. You will get half. Similarly, 1 upon 8, 1 upon 8, 1 upon 8, 4 times 1 upon 8. That is 4 upon 8. If you divide numerator and denominator of 4 upon 8 by 2, you will get 2 upon 4. And if you again divide numerator and denominator by 2, you will get 1 upon 2. So 4 upon 8 is equal to 2 upon 4 is equal to 1 upon 2. You can see it here. This length is equal to this length is equal to this length. What do you observe? Are the lengths 1 upon 2 and 2 upon 4 equal? Yes. Are the lengths 2 upon 4 and 4 upon 8 equal? Yes. We can say that 1 upon 2 is equal to 2 upon 4 is equal to 4 upon 8. These are equivalent fractions that denote the same length, but they are expressed in terms of different fractional units. Now, check whether 1 upon 3 and 2 upon 6 are equivalent fractions or not using paper strips. If you take a unit length paper strip and divide it into 3 equal parts such that one length is 1 upon 3. If you divide again into half of 1 upon 3, you will get 1 upon 6, 1 upon 6, 6 times. So you can see 2 1 upon 6 is equal to 1 upon 3. So you can say 2 upon 6 is equal to 1 upon 3. Make your own fraction wall using such strips as given in picture below. Answer the following questions after looking at the fraction wall. 1. Are the lengths 1 upon 2 and 3 upon 6 equal? You can see a unit length has been splitted in half, then 1/3, then 1/4, then 1/5 and 1/6 like this. It is asked, are the lengths half and 3 by 6 equal? Half is here, 3 by 6 is here. So you can say yes. 3 upon 6, if you divide numerator and denominator by 3, you will get half. 2. Are 2 by 3 and 4 by 6 equivalent fractions? Why? 2 by 3 is here and 4 by 6 is here. Yes, they are equivalent. If you divide numerator and denominator of 4 upon 6, you will get 2 upon 3. You have to divide it by 2. 3. How many pieces of length 1 upon 6 will make a length of 1 upon 2? 1, 2, 3. You can see 3 upon 6 is equal to 1 upon 2. So 3 times 1 upon 6. 3 pieces. 4. How many pieces of length 1 upon 6 will make a length of 1 upon 3? You can see 1 upon 3 is here. 1 piece and 2 piece. Answer is 2 pieces. If you take 2 1 upon 6, you will get 2 upon 6. If you divide numerator and denominator by 2, you will get 1 upon 3. So 2 upon 6 is equal to 1 upon 3. We can extend this idea to make a fraction wall up to the fractional unit 1 upon 10. This fraction wall is given at the end of the book. You can see 1 unit length has been split in 2 halves, that is 2 parts, then 3 parts, then 4 parts, like this. Similarly, 10 equal parts in the last one. Figure it out. 1 are 3 upon 6, 4 upon 8, 5 upon 10, equivalent fractions y. 3 upon 6. 3 upon 6 is here, 4 upon 8 is here, and 5 upon 10 is here. They are laying in same vertical line, so they are equivalent fraction. You can figure it out like this. 3 upon 6, if you divide numerator and denominator by 3, you will get 1 upon 2. Or 4 upon 8, if you divide numerator and denominator by 2, you will get 2 upon 4. Again by 2, you will get 1 upon 2. Similarly, for 5 upon 10, if you divide numerator and denominator by 5, you will get 1 upon 2. Since all are equal to 1 upon 2, they should be equivalent fractions. To write two equivalent fractions for 2 upon 6. 2 upon 6 can be written as 1 upon 3 after dividing numerator and denominator by 2. In this fractional wall, 2 upon 6 is here. Equivalent to that is 3 upon 9 and 1 upon 3. So you can write 2 upon 6 is equal to 3 upon 9 is equal to 1 upon 3. 1 upon 3 and 3 upon 9. We got 1 upon 3 by dividing 2 upon 6 by 2. If we multiply 1 upon 3 with 3 upon 3, we will get 3 upon 9. 3, 4 upon 6 is equal to dash, 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 and so on. Write as many as you can. 4 upon 6 is here. It is equal to 2 upon 3, 6 upon 9, 2 upon 3, 6 upon 9, and so on. For finding that, you have to divide or multiply the numerator using the same number. 4 upon 6 after dividing with 2, you will get 2 upon 3. 2 upon 3, if you multiply it by 2 upon 2, you will get 4 upon 6. Similarly, since 4 upon 6 is equal to 2 upon 3, you can multiply 2 upon 3 by 3 upon 3. You will get 6 upon 9. Similarly, 2 upon 3 can be multiplied with 4 upon 4. You will get 8 upon 12. Similarly, 2 upon 3 can be multiplied with 5 upon 5. You will get 10 upon 15. Similarly, 2 upon 3 can be multiplied with 6 upon 6. You will get 12 upon 18. These numbers are equivalent fractions. You can write it here. Here 8 upon 12, 10 upon 15, 12 upon 18, and so on. Understanding equivalent fractions using equal shares. One roti was shared equally by 4 children. What fraction of the whole did each child get? You can see here, one roti has been splitted in 4 children. So each will get 1/4. The adjoining picture shows the division of a roti among 4 children. Fraction of roti each child got is 1/4. The 4 shares must be equal to each other. You can also express this event through division facts, addition facts, and multiplication facts. The division fact is 1 divided by 4 is equal to 1/4. The addition fact is 1 is equal to 1/4 plus 1/4 plus 1/4 plus 1/4. The multiplication fact is 1 is equal to 4 times 1/4. Figure it out. 1. 3 rotis are shared equally by 4 children. Show the division in the picture and write a fraction for how much each child gets. Also, write the corresponding division facts, addition facts, and multiplication facts. You can see 3 rotis are there and it should be shared in 4 children. Fraction of roti each child gets is, using division fact, 3 divided by 4. So, each child will get 3/4. Addition fact, 3 can be written as 4 times 3/4. 3/4, 3/4, 3/4 added 4 times. Multiplication fact, 3 can be written as 4 multiplied to 3/4. You can do in another way. 1 roti has 4 quarters. 3 roti will have 4 into 3, that is 12 quarters. 12 1/4 has to be splitted in 4 parts. So you have to divide it by 4. The answer will be 3/4. Compare your picture and answers with your classmates. 2. Draw a picture to show how much each child gets when 2 rotis are shared equally by 4 children. Also, write the corresponding division facts, addition facts, and multiplication facts. You have to divide 2 rotis in 4 children. Division fact, 2 divided by 4 is equal to 2/4 is equal to 1/2. Each child will get half. Similarly, addition fact, 2 has to be split in 4 parts. So, 4 times 1/2. Adding them will give you 2. Multiplication fact, 4 times 1/2. 3. Anil was in a group where 2 cakes were divided equally among 5 children. How much cake would Anil get? 2 cakes to be distributed in 5 children. Each will get 2 by 5. This girl says, now if there are 10 children in my group, how many cakes will I need so that they get same amount of cake as Anil? 2/5 share by each earlier. Now there are 10 children. So the number of cakes will be double of the original since number of children has doubled. Double of 2 is 4. 4 cakes are required. What if we put 2 such groups together? One group where 2 cakes are divided equally between 5 children and another group again with 4 cakes and 10 children. In one group, 5 children are there and 2 cakes are there. And in another group, 4 cakes are there and 10 children are there. You already know 4 upon 10 is equal to 2 upon 5. Each will get 2 upon 5 share of the cake present. In group 1, 2 cakes to be distributed in 5 children. In group 2, 4 cakes to be distributed in 5 and 5, 10 children. You can see same arrangement could be made in group 2. So each child's share will be 2 upon 5. Or you can understand like this. 4 to be distributed in 10. If you divide numerator and denominator by 2, you will get 2 upon 5. This girl says, so the share of each child is the same in both these situations. So 2 upon 5 is equal to 4 upon 10. Let us examine the shares of each child in the following situations. One roti is divided equally between 2 children. 2 rotis are divided equally among 4 children. 3 rotis are divided equally among 6 children. Let us draw and share. Did you notice that in each situation the share of every child is the same? So we can say that 1 upon 2 is equal to 2 upon 4 is equal to 3 upon 6. You can see it here. One roti is divided equally between 2. You can see share of every child is half. 2 rotis are divided equally among 4. You can see 2 rotis and 4 children. Share of every child is 2 upon 4 or is equal to 1 upon 2. 3 rotis are divided equally among 6. You can see 3 rotis and 6 children. Share of every child is 3 upon 6 is equal to half. Thus, you can say 1 upon 2 is equal to 2 upon 4 is equal to 3 upon 6. Fractions where the shares are equal are called equivalent fractions. So 1 upon 2, 2 upon 4 and 3 upon 6 are all equivalent fractions. Find some more fractions equivalent to 1 upon 2. Write them in the boxes here. You can see 2 upon 4 is obtained by multiplying 1 upon 2 by 2 by 2. Similarly, 3 upon 6 can be obtained by multiplying 3 upon 3 to 1 upon 2, you will get 3 upon 6. Similarly, by multiplying 4 upon 4 in 1 upon 2, you will get 4 upon 8. Similarly, by 5 upon 5, you will get 5 upon 10. Similarly, 6 upon 6, 6 upon 12. Similarly, 7 upon 7, 7 upon 14. Similarly, 8 upon 8, you will get 8 upon 16. These fractions are equivalent fractions. So, 2 have been given here. You can write others here, such as 5 upon 10, 6 upon 12, 7 upon 14, 8 upon 16, like that. Equally divide the rotis in the situations shown below and write down the share of each child. Are the shares of each of these cases the same? Why? Two rotis divided equally among 3 children. Share of each child is 2 upon 3. 4 rotis divided equally among 6 children. Share of each child is 4 upon 6. 4 upon 6. 4 upon 6, that is equal to 2 upon 3. 4 upon 6. 4 upon 6. 4 upon 6. Similarly, 6 rotis divided equally among 9 children. 6 rotis and 9 children. Share of each child is 6 upon 9. Six upon 9 is equal to 2 upon 3. When you divide 6 by 3 and 9 by 3, you will get 2 upon 3. So you can say 2 upon 3, 4 upon 6 and 6 upon 9 are equivalent fractions. 2 upon 3 is called the simplest form of 4 upon 6. It is also the simplest form of 6 upon 9 as well. This girl says, do you notice anything about the relationship between the numerator and denominator in each of these fractions? You can see, if a fraction is like 2 upon 3, while finding out its equivalent fraction, both denominator and numerator multiplied by same number. For example, if I multiply 2 and 3 by 5, the new fraction will be 10 upon 15, which is a equivalent fraction of 2 upon 3, 4 upon 6 and 6 upon 9 and so on. Figure it out. Find the missing numbers. A. 5 glasses of juice shared equally among 4 friends is the same as dash glasses of juice shared equally among 8 friends. So 5 upon 4 is equal to dash upon 8. You can see the denominator has doubled. So you have to double the numerator too. So you have to write 10 here. 4 friends require 5 glasses of juice. So 8 friends will require 10 glasses of juice. Just double of the previous one. B. 4 kg of potatoes divided equally in 3 bags is the same as 12 kilograms of potatoes divided equally in dash bags. So 4 upon 3 is equal to 12 upon dash. 4 kg potatoes divided in 3 bags. So 12 kg potatoes, that is 3 times of 4, will be divided in 9 bags. So you have to write 9 here. C. 7 rotis divided among 5 children is the same as dash rotis divided among dash children. So 7 upon 5 is equal to dash. upon dash. For example, if you double the number of children, then you have to double the number of rotis. If you triple the number of children, then you need triple number of rotis. If you quadruple the number of children, then you have to quadruple the number of rotis. So you can fill 14 upon 10 or 21 upon 15 or 28 upon 20, so on. In which group will each child get more chickie? One chickie divided between two children or five chickies divided among eight children. In first case, the share is 1 upon 2. In the second case, the share is 5 upon 8. To compare, you have to make the denominator same. So 1 upon 2 should be multiplied by 4 upon 4 so that denominator becomes 8. Numerator will become 4. Since 4 upon 8 is less than 5 upon 8, you can say in the second case, the share of chickie is more. That means 5 upon 8 is greater than 1 upon 2. Mukta, so we must compare 1 upon 2 and 5 upon 8, which is more. Sabnam, well, we have seen that 1 upon 2 is equal to 4 upon 8, and clearly 4 upon 8 is less than 5 upon 8. So, the children for whom 5 chickies is divided equally among 8 will get more than those children for whom 1 chickie is divided equally among 2. The children in the second group will get more chickie each. What about the following groups? In which group will each child get more? 1 chickie divided between 2 children or 4 chickies divided among 7 children. In the first case, the share is 1 upon 2. In the second case, the share is 4 upon 7. If we multiply 1 upon 2 by 4 upon 4, then you will get 4 upon 8. You have to compare 4 upon 8 with 4 upon 7. 4 upon 8 means 4 things are distributed in 8 children, and 4 upon 7 means 4 things are distributed in 7 children. Since number of children is more here, the share will be less. So you can say 4 upon 8 is less than 4 upon 7, or you can say 1 upon 2 is less than 4 upon 7. So in the second case, share will be more. Subnum, the children of which group will get more chickie this time? Mukta, we must compare 1 upon 7 and 4 upon 7. By mistake, here written 1 upon 7. Mukta said, we must compare 1 upon 2 and 4 upon 7. Now, 1 upon 2 multiplied by 4 upon 4 is equal to 4 upon 8. So, 1 upon 2 is equal to 4 upon 8. Subnum, but why did you multiply the numerator and denominator by 4 again? Mukta, you will see. This girl says, When 4 chickies are divided equally among 4 children, each one will get 4 by 7 or 4 upon 7 chickie. When 4 chickies are divided equally among 8 children, each one will get 4 upon 8 chickie. So 4 upon 7 is more than 4 upon 8. If the number of units that are shared is the same, but the number of children among whom the units are shared is more, then the share is less. Therefore, 4 upon 7 is greater than 4 upon 8 and 4 upon 8 is equal to 1 upon 2. So, 4 upon 7 is greater than 1 upon 2. Now, I understood why you multiplied the numerator and denominator by 4. Another way of doing that is, if you have to compare 1 upon 2 and 4 upon 7, just make the denominator equal. You can see 8 upon 14 is more than 7 upon 14. So you can say 4 upon 7 is more than 1 upon 2. Suppose the number of children is kept the same, but the number of units are being shared is increased. What can you say about each child's share now? Why? Discuss how your reasoning explains. 1 upon 5 is less than 2 upon 5. One thing distributed in 5 children will be less than 2 things distributed in 5 children. 3 upon 7 is less than 4 upon 7. Similarly, 1 upon 2 is less than 5 upon 8. Now decide in which of the two groups will each child get a larger share. 1. Group 1. 3 glasses of sugarcane juice divided equally among 4 children. Group 2. 7 glasses of sugarcane juice divided equally among 10 children. In the first case, share of each child will be 3 upon 4. In the second case, share of each child will be 7 upon 10. You can make numerator equal or denominator. For simplicity, I am making denominator equal. You will get 15 upon 20 here. You will get 14 upon 20 here. So, the second group will get less share. The answer is the first group got the more share. Since 15 upon 20 is greater than 14 upon 20, or you can say 3 upon 4 is greater than 7 upon 10. So group 1 got larger share. 2. Group 1 4 glasses of sugarcane juice divided equally among 7 children. Group 2 5 glasses of sugarcane juice divided equally among 7 children. Now you can see number of children is same. 4 things divided in 7 children. 5 things divided in 7 children. So the second group will get larger share. Which groups were easier to compare? Why? When the number of children is the same, it is easier to compare, isn't it? Subnum. To compare the first two groups, we have to find fractions equivalent to the fractions 3 upon 4 and 7 upon 10. Mukta. How about 6 upon 8 equal to 3 upon 4 and 21 upon 30 equal to 7 upon 10? Subnum. There is a condition. The fractional unit used for the two fractions have to be the same, like 2 upon 6 and 3 upon 6. Both use the same fractional unit 1 upon 6, that is, the denominators are the same. But 6 upon 8 and 21 upon 30 do not use the same fractional units. They have different denominators. Mukta. Okay. So let us start making equivalent fractions then. 3 upon 4 is equal to 6 upon 8 is equal to 9 upon 12 is equal to 12 upon 16 is equal to 15 upon 20 dash dash dash. But when do I stop? Sabnam. Got it. How about we go on till 4 into 10, that is 40. Mukta, you mean the product of the two denominators? Sounds good. We have 3 upon 4 and 7 upon 10. The product of the two denominators 4 and 10 is 40. You can see equivalent fractions here such that its denominator becomes 40. Similarly, equivalent fraction of 7 upon 10 such that its denominator becomes 40. Now you can compare 30 upon 40 and 28 upon 40. Since 30 upon 40 is larger than 28 upon 40, you can say 3 upon 4 is larger than 7 upon 10. Go till we reach the denominator 40. But notice that 15 upon 20 and 14 upon 20 also had the same denominator. You can see 15 upon 20 here and 14 upon 20. You can compare these two. You will get 3 upon 4 is greater than 7 upon 10. Yes, we just needed to get the same fractional units for each fraction. Subnum. So, fractions equivalent to 3 upon 4 and 7 upon 10 with the same fractional unit, same denominators are 30 upon 40 and 28 upon 40 or 15 upon 20 and 14 upon 20. Since clearly 30 upon 40 is greater than 28 upon 40, we conclude that 3 upon 4 is greater than 7 upon 10. Find equivalent fractions for the given pairs of fractions such that the fractional units are the same. 7 upon 2 is equal to 14 upon 4 is equal to 21 upon 6 is equal to 28 upon 8 is equal to 35 upon 10. Similarly, 3 upon 5 is equal to 6 upon 10. You can see denominator 10 here, denominator 10 here. Stop there. You can compare these two. You can see 35 upon 10 is greater than 6 upon 10. So 7 upon 2 will be more than 3 upon 5. B. 8 upon 3 and 5 upon 6. 8 upon 3 and 5 upon 6. 16 upon 6. You can see 6 is already there in both the fractions. So you can compare these. Thus you can say 16 upon 6 is greater than 5 upon 6. So 8 upon 3 will be greater than or larger than 5 upon 6. C. 3 upon 4 and 3 upon 5. 3 upon 4, 3 upon 5. Equivalent fraction of 3 upon 4 is 6 upon 8, 9 upon 12, 12 upon 16, 15 upon 20. Equivalent fraction of 3 upon 5 is 6 upon 10, 9 upon 15, and then 12 upon 20. Now you can compare these two fractions since their denominators is same, 20. You can see 15 upon 20 is greater than 12 upon 20. So you can say 3 upon 4 is greater than 3 upon 5. You can directly say since 3 distributed in 4 and since 3 is distributed in 5, 3 distributed in 4 will be larger than 3 distributed in 5. Similarly, you can try D, E, F, G and H. Expressing a fraction in lowest terms or in its simplest form. In any fraction, if its numerator and denominator have no common factor except 1, then the fraction is said to be in lowest terms or in its simplest form. In other words, a fraction is said to be in the lowest term if its numerator and denominator are as small as possible. Any fraction can be expressed in lowest terms by finding an equivalent fraction whose numerator and denominator are as small as possible. Let us see how to express fractions in lowest terms. Example: is the fraction 16 upon 20 in lowest terms? No, 4 is a common factor of 16 and 20. Let us reduce 16 upon 20 to lowest terms. We know that both 16 numerator and 20 denominator are divisible by 4. So 16 divided by 4 upon 20 divided by 4 is equal to 4 upon 5. Now there is no common factor between 4 and 5. Hence 16 upon 20 expressed in lowest terms is 4 upon 5. So 4 upon 5 is called the simplest form of 16 upon 20 since 4 and 5 have no common factor other than 1. Another way of doing this, just divide by 2 as they are even. You will get 8 upon 10. Again by 2, you will get 4 upon 5. This girl says any fraction can be converted to lowest terms by dividing both the numerator and denominator by the highest common factor between them. Expressing a fraction in lowest terms can be also done in steps. Suppose we want to express 36 upon 60 in lowest terms. First, we notice that both the numerator and denominator are even. So, we divide both by 2 and see that 36 upon 60 is equal to 18 upon 30. Both the numerator and denominator are even again. So, we can divide them each by 2 again. We get 18 upon 30 is equal to 9 upon 15. We now notice that 9 and 15 are both multiples of 3. So we divide both by 3 to get 9 upon 15 is equal to 3 upon 5. Now 3 and 5 have no common factor other than 1. So 36 upon 60 in lowest terms is 3 upon 5. 36 upon 60 is equal to 18 upon 30 is equal to 9 upon 15 is equal to 3 upon 5. Alternatively, we could have noticed that in 36 upon 60, both the numerator and denominator are multiples of 12. we see that 36 is equal to 3 into 12 and 60 is equal to 5 into 12. Therefore, we could have concluded that 36 upon 60 is equal to 3 upon 5 straightway. Either method works and will give the same answer, but sometimes it can be easier to go in steps. 36 upon 60 divided by 12 will give 3 upon 5. Figure it out. Express the following fractions in lowest terms. A 17 upon 51. Just divide the numerator and denominator by 17. You will get 1 upon 3. B 64 upon 144. Dividing by 2 will give 32 upon 72. Again by 2, 16 upon 36. Again by 2, 8 upon 18. Again by 2 will give you 4 upon 9. Now it is not possible to simplify further. So the answer is 4 upon 9. You can do it directly. You can directly divide 64 and 144 by 16. You will get 4 upon 9. E 126 upon 147. 126 upon 147. Dividing by 3. And again dividing by 7. You will get 6 upon 7. D 525 upon 112. Try doing that. 7.7 Comparing fractions. Which is greater, 4 upon 5 or 7 upon 9? It can be difficult to compare two such fractions directly. However, we know how to find fractions equivalent to two fractions with the same denominator. Let us see how we can use it. 4 upon 5 is equal to 36 upon 45 when we multiply numerator and denominator by 9. You can say equivalent fraction of 4 upon 5 is 36 upon 45. Similarly, equivalent fraction of 7 upon 9 is 35 upon 35 by multiplying numerator and denominator by 5. You can see these two fractions have the same denominator, that is 45. Now you can compare the numerator. 36 upon 45 is more than 35 upon 45. So you can say 4 upon 5 is more than 7 upon 9. 45 is a common multiple of 5 and 9. So we can use 45 as a common denominator. Clearly, 36 upon 45 is greater than 35 upon 45. So 4 upon 5 is greater than 7 upon 9. Let us try this for another pair, 7 upon 9 and 17 upon 21. 7 upon 9 and 17 upon 21. If you make the denominator 63, by multiplying 7 upon 9 by 7 upon 7 and 17 upon 21 by 3 upon 3, you can compare the numerator. the fractions become 49 upon 63 and 51 upon 63. You can see this is more. So you can say 17 upon 21 is larger than 7 upon 9. 63 is a common multiple of 9 and 21. We can then write 7 upon 9 is equal to 7 upon 9 multiplied by 7 upon 7 is equal to 49 upon 63. 17 upon 21 is equal to 17 upon 21 multiplied by 3 upon 3 is equal to 51 upon 63. Clearly, 49 upon 63 is less than 51 upon 63. So, 7 upon 9 is less than 17 upon 21. Let's summarize. Steps to compare the sizes of two or more given fractions. Step 1. Change the given fractions to equivalent fractions so that they all are expressed with the same denominator, same fractional unit. Step 2. Now compare the equivalent fractions by simply comparing the numerators, that is, the number of fractional units each has. Figure it out. 1. Compare the following fractions and justify your answers. A. 8 upon 3 and 5 upon 2. 8 upon 3 and 5 upon 2. Common factor of 3 and 2 is 6. Just multiply by 3. You will get 15 upon 6. Similarly, 6 here in the denominator, that is double of 3. Then double of 8 is 16. So 16 upon 6 is more than 15 upon 6. So you can say 8 upon 3 is greater than 5 upon 2. B. 4 upon 9, 3 upon 7. 4 upon 9, 3 upon 7. Common factor of 7 and 9, that is denominator, 63. So multiply the first one by 7 upon 7 and the second one by 9 upon 9. You can see 28 upon 63 is greater than 27 upon 63. So you can say 4 upon 9 is greater than 3 upon 7. C. 7 upon 10, 9 upon 14. Common factor of 10 and 14 is 70. So just multiply by 7 upon 7 with first one and 5 upon 5 in the second one. You can see 49 upon 70 is larger than 45 upon 70. So you can say 7 upon 10 is larger than 9 upon 14. Similarly, you can do D and E. 2. Write the following fractions in ascending order. A. 7 upon 10, 11 upon 15, 2 upon 5. For this question, you have to make equivalent fraction for every fractions. Common factor of 10, 15 and 5 is 30. You can see The smallest one is 12 upon 30, that is 2 upon 5. Then 21 upon 30, that is 7 upon 10. Then 22 upon 30, that is 11 upon 15. B. 19 upon 24, 5 upon 6, 7 upon 12. You can see common factor of 24, 6 and 24 is 24. So 19 upon 24 can be written as 19 upon 24. Similarly, 5 upon 6 can be written as 20 upon 24. Similarly, 7 upon 12 can be written as 14 upon 24. You can see the smallest one is 7 upon 12. Then 19 upon 24. Then 5 upon 6. 3. Write the following fractions in descending order. A. 15 upon 16, 7 upon 8, 13 upon 4, 17 upon 32. Common factor of denominators is 32. 25 upon 16 can be written as 15 upon 32. 7 upon 8 can be written as 28 upon 32. 13 upon 4 can be written as 104 upon 32. And 17 upon 32 is same. You can see the largest one is 104 upon 32. So 13 upon 4 will be the largest one. Then 50 upon 32 or 25 upon 16. Then 28 upon 32, that is 7 upon 8. Then 17 upon 32. Last one. This is in descending order. B. 3 upon 4, 12 upon 5, 7 upon 12, 5 upon 4. Common multiple of 4, 5, 12 and 4 is 60. Try doing this. 7.8. Addition and subtraction of fractions. Mina's father made some chicky. Mina ate half of it and her younger brother ate 1/4 of it. How much of the total chicky did Mina and her brother eat together? We can arrive at the answer by visualizing it. Let us take a piece of chicky and divide it into two halves first like this. Mina ate half. Mina ate half of it as shown in the picture. Let us now divide the remaining half into two further halves as shown. Each of these pieces is 1/4 of the whole chicky. Brother ate 1/4, Mina ate half. Mina's brother ate 1/4 of the whole chicky as is shown in the picture. The total chicky eaten is 1/2 by Meena and 1/4 by her brother. The total chicky eaten is 1 by 2 or 1 upon 2 plus 1 upon 4. 1 upon 2 can be written as 2 1 upon 4, or it can be written as 3 times 1 upon 4 equal to 3 upon 4. How much the total chicky is remaining? You can see 1 upon 4. You can find it like this by subtracting 3/4 from 1. 1 can be written as 4 upon 4. So the remaining portion of chicky is 1 upon 4. Adding fractions with the same fractional unit or denominator. Example: find the sum of 2 upon 5 and 1 upon 5. Let us represent both using rectangular strips. In both fractions, the fractional unit is the same, 1 upon 5. So each strip will be divided into 5 equal parts. So 2 upon 5 will be represented as, and 1 upon 5 will be represented as. Adding the two given fractions is the same as finding out the total number of shaded parts, each of which represent the same fractional unit 1 upon 5. In this case, the total number of shaded parts is 3. Since each shaded part represents the fractional unit 1 upon 5, we see that 3 shaded parts together represent the fraction 3 upon 5. Therefore, 2 upon 5 and 1 upon 5 when added will give 3 upon 5, like this. Example: find the sum of 4 upon 7 and 6 upon 7. Let us represent both again using the rectangular strip model. Here is both fractions. The fractional unit is the same, that is 1 upon 7. So each strip will be divided into 7 equal parts. Then 4 upon 7 will be represented as, and 6 upon 7 will be represented as. In this case, the total number of shaded parts is 10, and each shaded part represents the fractional unit 1 upon 7. So the 10 shaded parts together represent the fraction 10 upon 7 as seen here. While adding fractions with the same fractional unit, just add the number of fractional units from each fraction. Therefore, 4 upon 7 plus 6 upon 7 is equal to 10 upon 7. It can be written as 1 plus 3 upon 7. It can be also written as 1 whole 3 upon 7. Try adding 4 upon 7 and 6 upon 7 using a number line. Do you get the same answer? This is 1 upon 7, 2 upon 7, 3 upon 7, 4 upon 7, 5 upon 7, 6 upon 7, and 1 can be written as 7 upon 7. Similarly, this one 8 upon 7, 9 upon 7, 10 upon 7, 11 upon 7, 12 upon 7, and 13 upon 7. You have to add 6 upon 7 in 4 upon 7. 4 upon 7 is here. 1, 2, 3, 4, 5, 6. This portion is 6 upon 7. So 4 upon 7 plus 6 upon 7 will give you 10 upon 7. That is 3 upon 7 more than 1, or can be written as 1 plus 3 upon 7 or 1 whole 3 upon 7, like this. Adding fractions with different fractional units or denominators. Example, find the sum of 1 upon 4 and 1 upon 3. To add fractions with different fractional units, first convert the fractions into equivalent fractions with the same denominator or fractional units. In this case, the common denominator can be made by multiplying 3 to 4, that is 12. That is, we can find equivalent fraction with fractional unit 1 upon 12. Let us write the equivalent fraction for each given fraction. 1 upon 4 can be written as 3 upon 12. 1 upon 3 can be written as 4 upon 12. Now 3 upon 12 and 4 upon 12 have the same fractional unit, that is 1 upon 12. Therefore 1 upon 4 plus 1 upon 3 is equal to 3 upon 12 plus 4 upon 12 is equal to 7 upon 12. This method of addition, which works for adding any number of fractions, was first explicitly described in general by Brahmgupta in the year 628 CE. We will describe the history of the development of fractions in more detail later in the chapter. For now, we simply summarize the steps in Brahmgupta's method for addition of fractions. Brahmgupta's method for adding fractions. 1. Find equivalent fractions so that the fractional unit is common for all fractions. This can be done by finding a common multiple of the denominators, that is, product of the denominator or the smallest common multiple of the denominators. 2. Add these equivalent fractions with the same fractional units. This can be done by adding the numerators and keeping the same denominator. 3. Express the result in lowest terms if needed. Let us carry out another example of Brahmgupta's method. Example, find the sum of 2 upon 3 and 1 upon 5. The denominator of the given fractions are 3 and 5. The lowest common multiple of 3 and 5 is 15. Then we see that 2 upon 3 can be written as 10 upon 15. 1 upon 5 can be written as 3 upon 15. Therefore, 2 upon 3 plus 1 upon 5 is equal to 10 upon 15 plus 3 upon 15 is equal to 13 upon 15. Example, find the sum of 1 upon 6 and 1 upon 3. The smallest common multiple of 6 and 3 is 6. 1 upon 6 will remain 1 upon 6. 1 upon 3 can be written as 2 upon 6. Therefore, 1 upon 6 plus 1 upon 3 is equal to 1 upon 6 plus 2 upon 6 is equal to 3 upon 6. The fraction 3 upon 6 can be re-expressed in lowest terms if desired. This can be done by dividing both the numerator and denominator by 3, the biggest common factor of 3 and 6. 3 upon 6 when divided by 3 upon 3 will give you 1 upon 2. Therefore, 1 upon 6 plus 1 upon 3 is equal to 1 upon 2. Figure it out. 1. Add the following fractions using Brahmgupta's method. A. 2 upon 7, 5 upon 7, 6 upon 7 when added up. Since denominator is same, you can add the numerator. 13 upon 7. It can be written as 1 whole 6 upon 7. B. 3 upon 4 plus 1 upon 3. Common multiple of 4 and 3 is 12. The answer is 13 upon 12. Can be written as 1 whole 1 upon 12. C. 2 upon 3 plus 5 upon 6. 2 upon 3 can be written as 4 upon 6. 5 upon 6 remains same. The answer is 9 upon 6. Can be simplified further by dividing with 3. The answer is 1 whole 1 by 2. D. 2 upon 3 plus 2 upon 7. Common multiple of 3 and 7 is 21. The answer is 20 upon 21. E. 3 upon 4 plus 1 upon 3 plus 1 upon 5. Common multiple of 4, 3 and 5 is 60. 3 multiplied to 15. 1 multiplied to 20. 1 multiplied to 12. 45 plus 20 plus 12. 77 upon 60. It can be written as 1 whole 17 upon 60. Similarly, you can try F, G, H, I, J. I am doing K, L, M. K, 3 upon 4 plus 1 upon 3 plus 1 upon 5. Similarly, common multiple of 4, 3 and 5 is 60. 3 multiplied to 15, 1 multiplied to 20 and 1 multiplied to 12. I think the same question have been repeated. The answer is 77 upon 60. L, 2 upon 3 plus 4 upon 5 plus 3 upon 7. I am doing it here. Common multiple of 3, 5 and 7 is 105. 2 multiplied to 35. Similarly, M, Common multiple of 2, 4, 6 is 12. 9 multiplied to 6, 5 multiplied to 3, 7 multiplied to 2. 73 upon 12 can be written as 6 whole 1 upon 12. 2. Rahim mixes 2 upon 3 liter of yellow paint with 3 upon 4 liter of blue paint to make green paint. What is the volume of green paint he has made? Yellow when mixed to blue will give you green. You have to add 2 upon 3 to 3 upon 4. Common multiple of 3 and 4 is 12. So you have to multiply 2 with 4 and 3 with 3. The answer is 1 whole 5 upon 12. 3. Geeta bought 2 upon 5 meter of lace and Samim bought 3 upon 4 meter of the same lace to put a complete border on a tablecloth whose perimeter is 1 meter long. Find the total length of the lace they both have bought. Will the lace be sufficient to cover the whole border? Let's find out. Length of the lace bought 2 upon 5 plus 3 upon 4. Common multiple of 5 and 4 is 20. 2 multiplied to 4 and 3 multiplied to 5. 1 whole 3 upon 20, which is greater than 1. Thus, you can say the lace length is sufficient to cover the whole border. Subtraction of fractions with the same fractional unit or denominator. Brahmgupta's method also applies when subtracting fractions. Let us subtract with the problem of subtracting 4 upon 7 from 6 upon 7, that is, what is 6 upon 7 minus 4 upon 7. Since denominator is same, you can say the answer is 2 upon 7. To solve this problem, we can again use the rectangular strips. In both fractions, the fractional unit is the same, that is 1 upon 7. Let us first represent the bigger fraction using a rectangular strip model as shown. This is 6 upon 7. Each shaded part represents 1 upon 7. Now we need to subtract 4 upon 7. To do this, let us remove 4 of the shaded parts like this. 4 parts removed. We have removed 4 upon 7. Left is 2 upon 7. Fractional parts to be removed. We can do this here directly because both fractions have the same fractional units. So we are left with two shaded parts, that is 6 upon 7 minus 4 upon 7 is equal to 2 upon 7. Try doing this Same exercise using the number line. This is 1 upon 7, 2 upon 7, 3 upon 7, 4 upon 7, 5 upon 7, 6 upon 7, and 1 can be written as 7 upon 7. You have to remove 4 upon 7 from 6 upon 7. This is 6 upon 7. 1 upon 7, 2 upon 7, 3 upon 7, and 4 upon 7. This portion is of length 4 upon 7. If this is removed, you will be left with 2 upon 7. Figure it out. 1. 5 upon 8 minus 3 upon 8. The answer is 2 upon 8 can be simplified as 1 upon 4. 2. 7 upon 9 minus 5 upon 9. The answer is 2 upon 9. 3. 10 upon 27 minus 1 upon 27. That is equal to 9 upon 27 can be written as 1 upon 3. Subtraction of fraction with different fractional units or denominators. Example, what is 3 upon 4 minus 2 upon 3? For doing this, just make the denominator equal. 3 upon 4 and 2 upon 3 has 3 and 4 as denominator. So multiply 3 upon 4 with 3 upon 3, you will get 9 upon 12, and multiply 2 upon 3 with 4 upon 4, you will get 8 upon 12. So 3 upon 4 minus 2 upon 3 can be written as 9 upon 12 minus 8 upon 12 equal to 1 upon 12. The answer is 1 upon 12. As we already know, the procedure for subtraction of fractions with the same fractional units, let us convert each of the given fractions into equivalent fractions with the same fractional units. 3 upon 4 can be written as 9 upon 12. Yes, by doing this, we can easily subtract the two fractions. Think, why did we choose to multiply both the numerator and denominator by 3? And similarly, 2 upon 3 can be written as 8 upon 12. Again, why did we choose to multiply both the numerator and denominator here by 4? Therefore, 3 upon 4 minus 2 upon 3 is equal to 9 upon 12 minus 8 upon 12 is equal to 1 upon 12. Brahmgupta's method for subtracting two fractions. 1. Convert the given fractions into equivalent fractions with the same fractional unit, that is the same denominator. 2. Carry out the subtraction of fractions having the same fractional units. This can be done by subtracting the numerators and keeping the same denominator. 3. Simplify the result into lowest terms if needed. Figure it out. 1. Carry out the following subtractions using Brahmgupta's method. A. 8 upon 15 minus 3 upon 15. The answer is 5 upon 15 or 1 upon 3. B. 2 upon 5 minus 4 upon 15. 2 upon 5 can be written as 6 upon 15 and 4 upon 15 same. The answer is 2 upon 15. C. 5 upon 6 minus 4 upon 9. Make the denominator same. That is 18. 5 can be multiplied to 3 and 4 can be multiplied to 2. 15 minus 8. The answer is 7 upon 18. Similarly, you can try D. 2. Subtract as indicated. A. 13 upon 4 from 10 upon 3. 10 upon 3 minus 13 upon 4. Common multiple of 3 and 4 is 12. 10 multiplied to 4 and 13 multiplied to 3. 40 minus 39 upon 12. 1 upon 12. The answer is 1 upon 12. B. 18 upon 5 from 23 upon 3. The answer is 4 whole 1 upon 15. Similarly, you can do C. 3. Solve the following problems. A. Jaya's school is 7 upon 10 km from her home. She takes an auto for half kilometer from her home daily and then walks the remaining distance to reach her school. How much does she walk daily to reach the school? Total distance is 7 upon 10. Distance covered using auto is half. You have to find the distance covered using walking. This distance will be 7 upon 10 minus 1 upon 2, or it can be written as 7 upon 10 minus 5 upon 10 equal to 2 upon 10 or 1 upon 5 kilometer. B. Jivika takes 10 upon 3 minutes to take a complete round of the park, and her friend Namit takes 13 upon 4 minutes to do the same. Who takes less time and by how much? 10 upon 3 and 13 upon 4, making the denominator same. You can see 40 upon 12 is more than 39 upon 12. So you can say 10 upon 3 is more than 13 upon 4. This time is less, so you can say Namit takes less time. And difference in time will be 10 upon 3 minus 13 upon 4 equal to 40 upon 12 minus 39 upon 12 equal to 1 upon 12. The answer is 1 upon 12 minutes. 7.9. A pinch of history. Do you know what a fraction was called in ancient India? It was called bhin in Sanskrit, which means broken. It was also called bhag or ans, meaning part or piece. The way we write fractions today globally originated in India. In ancient Indian mathematical texts, such as the Baksali manuscript from around the year 300 CE, when they wanted to write half, they wrote it as 1 and 2 below, which is indeed very similar to the way we write it today. This method of writing and working with fractions continued to be used in India for the next several centuries, including by Aryabhat 499 CE, Brahmgupta 628 CE, Sridharacharya 750 CE, and Mahaviracharya 850 CE, among others. The line segment between the numerator and denominator in half and in the other fractions was later introduced by Moroccan mathematician Al-Hassar in the 12th century. Over the next few centuries, the notation then spread to Europe and around the world. Fractions had also been used in other cultures such as the ancient Egyptian and Babylonian civilizations, but they primarily used only fractional units, that is, fractions with a 1 in the numerator. More general fractions were expressed as sum of the fractional units, now called Egyptian fractions. Writing numbers as the sum of fractional units, example 19 upon 24 is equal to 1 upon 2 plus 1 upon 6 plus 1 upon 8, can be quite an art and leads to beautiful puzzles. We will consider one such puzzle below. General fractions, where the numerator is not necessarily 1, were first introduced in India along with their rules of arithmetic operations like addition, subtraction, multiplication, and even division of fractions. The ancient Indian treatises called the Sulbasutra show that even during Vedic times, Indians had discovered the rules for operations with fractions. General rules and procedures for working with and computing with fractions were first confined formally and in a modern form by Brahmgupta. Brahmgupta's methods for working with and computing with fractions are still what we use today. For example, Brahmgupta described how to add and subtract fractions as follows. By the multiplication of the numerator and the denominator of each of the fractions by the other denominators, the fractions are reduced to a common denominator. Then, in case of addition, the numerators obtained after the above reduction are added. In case of subtraction, their difference is taken. Brahmgupta Brahmasphuta Siddhanta, verse 12.2, 628 CE. The Indian concept and methods involving fractions were transmitted to Europe via the Arabs over the next few centuries, and they came into general use in Europe in around 17th century and then spread whole world. Puzzle. It is easy to add up fractional units to obtain the sum 1. If one uses the same fractional unit, example 1 upon 2 plus 1 upon 2 is equal to 1, 1 upon 3 plus 1 upon 3 plus 1 upon 3 is equal to 1, 1 upon 4 plus 1 upon 4 plus 1 upon 4 plus 1 upon 4 is equal to 1, etc. However, can you think of a way to add fractional units that are all different to get 1? It is not possible to add two different fractional units to get 1. The reason is that 1 upon 2 is the largest fractional unit and 1 upon 2 plus 1 upon 2 is equal to 1. To get different fractional units, we would have to replace at least one of the 1 upon 2's with some smaller fractional unit, but then the sum would be less than 1. Therefore, it is not possible for two different fractional units to add up to 1. We can try to look instead for a way to write 1 as the sum of three different fractional units. 1. Can you find three different fractional units that add up to 1? It turns out there is only one solution to this problem up to changing the order of the three fractions. Can you find it? Try to find it before reading further. Here is a systematical way to find the solution. We know that 1 upon 3 plus 1 upon 3 plus 1 upon 3 is equal to 1. To get the fractional unit to be different, we will have to increase at least one of the 1 upon 3's and decrease at least one of the other 1 upon 3's to compensate for that increase. The only way to increase 1 upon 3 to another fractional unit is to replace it by 1 upon 2. So 1 upon 2 must be one of the fractional units. Now 1 upon 2 plus 1 upon 4 plus 1 upon 4 is equal to 1. To get the fractional units to be different, we will have to increase one of the 1 upon 4 and decrease the other 1 upon 4 to compensate for that increase. Now the only way to increase 1 upon 4 to another fractional unit that is different from 1 upon 2 is to replace it by 1 upon 3. So two of the fractions must be 1 upon 2 and 1 upon 3. What must be third fraction then, so that the three fractions add up to 1? This explains why there is only one solution to the above problem. 1 upon 2 plus 1 upon 3 plus 1 upon 6 is equal to 1. What if we look for 4 different fractional units that add up to 1? 2. Can you find 4 different fractional units that add up to 1? It turns out that this problem has 6 solutions. Can you find at least one of them? Can you find them all? You can try using similar reasoning as in the cases of 2 and 3 fractional units, or find your own method. Once you find one solution, try to divide a circle into parts like in the figure above to visualize it. Summary: fraction as equal shared. When a whole number of units is divided into equal parts and shared equally, a fraction results. Fractional units: when one whole basic unit is divided into equal parts, then each part is called a fractional unit. Reading fractions. In a fraction such as 5 upon 6, 5 is called the numerator and 6 is called the denominator. Mixed fractions contain a whole number part and a fractional part. Number line. Fractions can be shown on a number line. Every fraction has a point associated with it on the number line. Equivalent fractions. When two or more fractions represent the same share number, they are called equivalent fractions. Lowest terms. A fraction whose numerator and denominator have no common factor other than 1 is said to be in lowest terms or in its simplest form. Brahm-Gupta's method for adding fractions. When adding fractions, convert them into equivalent fractions with the same fractional unit. that is the same denominator, and then add the number of fractional units in each fraction to obtain the sum. This is accomplished by adding the numerators while keeping the same denominator. Brahm-Gupta's method for subtracting fractions. When subtracting fractions, convert them into equivalent fractions with the same fractional unit, that is the same denominator, and then subtract the number of fractional units and then subtract the number of fractional units. This is accomplished by subtracting the numerators while keeping the same denominator. For more videos, you can subscribe NCERT video. Thank you.